Hello, dear students. Welcome to the channel. Today onwards, we are stepping a move forward and we are starting a new playlist, or you can call it a new module in the signal and system module, in which we will be discussing the mathematical operations which will be taking place on different kind of signals, as well as different mathematical operations of systems. So in order to understand this playlist, I would recommend you that you must have gone through the basics of signal and system. What is a signal, what is a systems, few general properties of systems, and also few uh, different type of classifications, different ways to classify a signals. So you must know that in order to continue this playlist or this video series. um, Except for that, you also know few basic types of signals which we have discussed in the previous lecture series, like unit step signal, unit ramp signal, exponential signals, sine wave signals, unit impulse signals. Those signals which we have discussed already in previous lectures. So if you haven't watched the previous lectures or previous lecture series, and if you want to know about those signals, link will be flashing on the top right side corner of the screen. So please go and check that out. And if you already know that, so let's get started with this playlist. Okay. So first, let me give you a small glimpse what we are going to discuss here. So first, we will be starting with mathematical operations which will be taking place on the signals. And in that, what we will be discussing these mathematical signal operations. It will include amplitude scaling. We will see what is signal addition, what is signal subtraction, what is the multiplication of the signal, and what is the differentiation of a signal. We will see the integration of signal, and then we will see some signal properties which are related to time. We will see time scaling, we will see time shifting, and we will see the time reversal or the time folding property. All this mathematical operation, or you can also call these operations of different kind of properties of signal. In a way, they are nothing but characteristics of properties of my signal. So those properties are very helpful for signal processing operation if you are dealing with signals. So these operations are very fundamental and will be helpful each and every step you take in the signal processing. So first, this all these operations which I've discussed about are normally categorized in types or two parts, and they are categorized based on two types of variables, right? Because a signal consists of two types of variable. Those variable either be dependent or they will be independent variables, right? So some of the operations which I have mentioned here will be are carried on the dependent variables, and others are carried on the independent variables. So as we go through each and every individual operation, we will discuss whether it will be an independent variable based or dependent variable based signal operation, right? So firstly, let's see the operations on dependent variables first. So here on out, the operations which I'm going to discuss in this lecture so far will be mostly the uh, operations on dependent variable, right? So how do you decide it? So normally the amplitude, or you can call an instantaneous value of your signal, will be considered a dependent variable. Okay. And based on that, all the operations which are related to this signal amplitude, like addition, subtraction, uh, amplitude scaling, such operations are called dependent variables. Okay. Please keep in mind, I'm talking about amplitude scaling, I'm not talking about time scaling. The uh, properties which are related to time will be covered most probably in the next lecture or whenever we go through that. But firstly, we are going to discuss about the operations on dependent variable only, and that includes amplitude scaling, addition, subtraction, etc. Okay. So now first let's start with the amplitude scaling part of this of my signal. So what do we do in amplitude scaling? It is pretty simple, pretty much self-explanatory. What happens? The amplitude scaling is an operation of changing the amplitude of a given continuous time signal. Or for that case, you can also consider a discrete time signal, right? So what do? We take a signal. Let's take a signal x of t is equals to u of t. U of t is my unit time step signal. Now what do? We multiply my this signal of ours with some constant value, and when we do it, we get the resultant value as y of t is equals to a into x of t. Here please notice what I'm doing. I'm taking some constant value. A is a constant value. A is not a signal itself. A is some constant value. So A is going to be 2, 3, 4, but A will not going to be r of t or delta t. Okay, it is not a signal, it is some value. So when we do that, what kind of result will we get? The y of t, right? So y of t will be the amplitude scaled version of x of t, right? And this scaling will be decided based on the constant, the a, right? So based on this a or based on this constant, we will get the different values or different versions of x of t. Okay, and always keep in mind whenever we talk about amplitude scaling in particular, amplitude scaling always takes place on the y-axis. It never takes place on x-axis. Okay, so let's see the example what will happen here. In the first image you can see this is my original signal x of t is equals to u of t, which is nothing but unit step signal. So 0 onwards its value will be 1 continuously till infinity or till t amount of time, and before 0 it holds the values 0. Okay, so for t x of minus 1, u of t will be 0, x of minus 2, u of t will be 0, right? Then the value, let's try to take the value of t is equals to 2. So when we took the value t is equals to 2, what happened here? See, the amplitude was 1, see, amplitude got doubled. So what happened, this constant was got multiplied with my signal. Okay, so when we took a equal to 2, y of t is equals to 2 u of t, and c, here it was value the value, previous value was 1, and now current value is 2. Same what will happen when I take value of my a is minus 1, see, here I'm getting value minus 1. And same case when I take value of a is zero point 0.5, my value is zero point 0.5. Why it is 0.5? Because u of t is unit step signal. So any what is happening here, the values were previously 1. So when I multiply 1 with any constant, what will I get? An output will be constant value. Agreed, right? And now to discuss about the part on the left hand side of the y-axis. So the previous values for it were 0, and anything multiplied with 0 will be what? It will be 0. So on the left side of y-axis I'm getting only 0 values. Okay, now similarly let's try to see it for discrete time signals. This time my original signal x of u will be x of n will be u of n, and my y of n will be a into u of n. Okay, so here you can see in this image This image you can see, this is my u of n. For 0 it is holding value 1, and as we take sample, the value is not changing, it is staying 1. And I multiplied with a, and here we are taking value of a is equals to 2, and here I am getting 2 u of n. See, value got doubled, here value was 1, here value got 2, right? So that is amplitude scaling for you. This is how we scale the amplitude of my signal. Now let's quickly come to addition of two different signals. And here one thing that I want you all to notice, that this is different from amplitude scaling, because what did we do in amplitude scaling? Remember, we multiplied with a constant. But in addition of two signals, what we are doing, we are taking one signal, we are taking second signal, and we are adding those two signals. We are not adding any signal with any constant value. We are taking two signals and we are adding both of them. Okay, so now let's consider two signals to understand what is addition of signal. Let's first take x1 of t is equals to u of t, again my simple unit step signal. So again, the unit step signal you can see here, this is my unit step signal, as I have mentioned in the scaling operation as well. And I'm taking x2 of t is equals to r of t. What is r of t? R of t is my r of t is my ramp signal. R of t is my ramp signal, and you can see the ramp signal here. See, it is constructing a ramp. You can see here, for the value of time 0, it is having value 0. For the value of time 1, it is having 1 on the y-axis. For 2, it is having 2 on the y-axis, and it is moving forward in that manner. Now what will happen, see here, by adding two signals, what we are doing, we are taking x1 of t plus x2 of t, and what we will get will be y of t, or my resultant signal. So now to understand it better, even though we are considering the continuous time signal, let's let's take a number of samples at a fixed intervals. Okay, it is a continuous time signal only, but what we are doing, we are just taking some samples. Okay, we are just taking some values at in some regular intervals. So here see, at 2 it is having value 1, it is having continuously value 1. My x1 of t is having value 1 continuously. But let's see for x2 of t, what is happening. We took a value at uh, t equal to -2, it is having value -2. And you can also confirm it from this table I have mentioned here. See, for t is equals to -2, x1 of t, what is it, what value is it having? Because as it is unit step signal, it will be having the value 0, because every point before 0 will be 0, and every point with from 0 onwards it will be having value 1. So before 0 it is having 0, then x2 of t is equals to r of t. So see in the graph, for -2 it is holding, what value is it holding? It is holding -2. Similarly for -1, x1 of t is holding 0, x2 of t is holding -1. For 0 it is holding 1, x2 of t holding 0. For t is equals to 1, x1 of t is holding 1, x2 of t is holding 1, which you can also confirm from this graph as well, right? For 2c, it will be holding 2 here, 2 it is holding 2 here. Okay, unit step is holding 1 only. Now when we add those two signals, what basically we are going to do, we are going to take the points and we are simply going to add them, the values, like let's add them. Let's try to see the addition operation. First let's consider t is equals to -2 point. So for t is equals to -2 point, what is the value of my x1 of t? It is 0. And for the same point t is equals to -2, what is the value of my x2 of t? It is -2. What will be the what will be the addition of 0 plus -2? It will be -2. So we are mentioning -2. Let's take for t is equals to -1. For t is equals to -1, it is having 0, it is having -1. 0 plus -1, here 0 plus minus 1, it will be minus 1. Now let's see t is equals to 0. At t is equals to 0, what is it having? It is having 1. x1 of t is having 1 and x2 of t is having 0. So y of t will be 1. Now let's see for t is equals to 1. For t is equals to 1, it is again having x1 of t is having 1. And what is the value of x2 of t? It is also 1. So here we will take 1 plus 1 equal to 2. Now let's see for 2. For 2, it is x1 of t is having 1 and x2 of t is having 2. So what will be the value of 1 plus 2? It will be 3. And similarly, we can see for t is equals to 3, 4 and 5 as well, and we will get the values 4, 5 and 6. Now what we will do, we will plot this graph. We will plot this graph right below my original signal so that we can understand the difference here. Okay, so let's just take these points and just simply plot it here. So what we will get, see, this will be the graph we will be getting. See, for t is equals to minus 2, it is minus 2. T is equals to minus 1, it is minus 1. See here, it is minus 2, it is minus 1. Then we have value 1. So see here, it is having value 1. See, but this ramp signal did not had value 1, right? It had value 0, but my unit step signal had value 1. So what we are getting, we are doing addition. We are doing addition of signals. Same for 2, it will be having value 2. For 3, it will be having value 3. For 4, 4, 5 for 5 and 6 for 6. Okay, so that was for my you can say continuous time signal. And same thing will happen with the discrete time signal as well. So let's see quickly see one example of discrete time signal as well, so that we can get it clearly. So instead of x of t, we will have x1 of n, and instead of u of t, we will be having value u of n. And the plot u of n has been shown with this graph. You can see samples taken at interval at interval of one time step, and the value of all those samples is constant 1. So that is your unit step signal for discrete. And x2 of n, same ramp signal I'm taking, but this time it is in the discrete time form. Okay, so I'm mentioning, remember, there was a way to mention it, right? There was a way to mention it. What was the way? The sequential order. If I want to show my signal using using a sequential order, so what we will do, we will mention the values. So the arrow will indicate my origin point, and the value at origin point is 0. So it is 0. At minus 1, it is having minus 1. At minus 2, it is having minus 2. For 1, 2, 3, 4, 5, it is having values 1, 2, 3, 4 and 5. Now again, I have mentioned the values, particular values in this table here. For t is equals to this is a discrete signal. So for sample, for n is equals to minus 2, my unit step signal or x1 of n is having value 0 and x2 of n is having value minus 2, as you can see here and here. For for n is equals to minus 1, x1 of n is 0, x2 of n is minus 1. Again, you can see confirm it from the graph. And the sequential method of representing signal. For n equals to 0, x1 of t is 0, x2 of t is x1 of n is 0, x1 of n is 1 and x2 of n is 0. For n is equals to 1, x1 of n is 1, x2 of n is 1. For n equal to 2, x1 of n is 1, x2 of n is 2. N equal to 3, x1 of n is 1, x2 of n is 3. For n equal to 4, x1 of n is 1, x2 of n is 4. N equal to 5, x1 of n is 1 and x2 of n is 5. And again what we will do, we will again similarly just take addition of that. So 0 plus minus 2 is equals to minus 2, 0 plus minus 1 is equals to minus 1, 1 plus 0 1, 1 plus 1 2, 1 plus 2 3, 1 plus 3 4, 1 plus 4 5, and 1 plus 5 6, right? So we did nothing but the simple addition, just like we did when we saw the continuous time signal operations. And you can also again confirm it using this graph as well. See, minus 2 plus my sorry, for time minus 2, what is the value? 0. 0 plus same here, see, for time equal to minus 2, it is having value minus 2. So 0 plus minus 2, minus 2. Again see, 0 plus minus 1, minus 1. Here it is having value 1. So 1 plus 0, 1. Again 1 plus 1, 2. 1 plus 2, 3. 1 plus 3, 4. And please notice we have to take we have to consider the values on the y-axis, not the x-axis. So if you are getting confused that I'm saying 1, if I'm let's say for this 0th point, if I'm saying 1 plus 0, that means I'm considering this value, this one value which is on the y-axis, which is my amplitude of my signal. Okay, I will simply the plot. We will simply plot my resultant axis. We will simply plot my result signal. Now, similar to addition, we can also do the subtraction of two signals. And for subtraction operation, what we will do? Again, let's take uh, same two signals, but again remember, for subtraction operation the order matters. It matters which of the which of the signal you are considering first, and which signal is getting subtracted from which signal. So for subtraction operation, again let's consider a ramp signal and a unit step signal first for continuous time signal. So subtraction is also based on the same principle as the addition was. So rather than going into theory, let me just directly explain it to you. So come here, see, firstly we are taking r of t, and then we are taking u of t, and then what we are going to do, we are going to subtract this u of t from r of t. Okay, so let's try to check out the value first. So for r of t at t equal to minus 1, let's consider let's say this is my 0th point, so this point will be minus 1, right? So for point minus 1, what value is it holding? It is holding minus 1. So what will happen? Minus 1 plus 0, so my answer will be minus 1, right? So it will come here. Then for time t is equals to 0, r of t's value is 0, and time t is equals to 1, r of t's value is 1, right? So again 0 minus 1, right? What will be the value when you subtract nothing from 0? The value will be, sorry, when you subtract minus 1 from 0, the value will be 0. So we'll take here 0. Now for value 1, for t is equals to 1, what is the value? See, it is having value 1. Same for t is equals to 1, for my unit step signal it is 1. So 1 minus 1 is equals to again 0, so it will come 0 here. For t is equals to 2, it is having value 2. For t is equals to 2, it is having value 1. So 2 minus 1, it will be 1. So we are having value 1 here. For t is equals to 3, it is having value 3. For t is equals to 3, it is again having value 1. So 3 minus 2 is equals to 2, and we are getting value 2 here. See. So that is how we do the subtraction of a continuous time signal. And similarly for discrete time signal as well, I will not take more time in the discrete time signal, because by now I think pretty much it will be clear to you how subtraction takes place, but still with saying that, let's see that. So again, this is the same ramp signal but in discrete time, and here we are having the same unit time, my unit step signal, but again in the discrete phenomena. So again we are taking subtraction. See, for minus 1 what is the value? For minus 1 it is not having any value. See here, it is having 0, it is also having 0, so 0. At 0 it is having 0, it is having 1, so it will be minus 1. For 1 it is having 1, it is having 1, so it will be 1 minus 1, 0. For 2 it is having 2, it is having again 1, so 2 minus 1 is equals to 1. For 3 it is having value 3, and it is having 1, so 3 minus 1 is equals to 2. So I think it is pretty much clear to you. Again I'm telling you, please consider the amplitude value, which means the values on the y-axis, not the time value or the sample value, okay, which are mentioned on the x-axis. You may get confused between that, but please consider these value on the y-axis. Now let's see the multiplication operation of signals. Um Again, multiplication operation is similar, holds similar properties as addition operation. And what do we do? Again, we will be taking the same ramp signal, but this time we will taking a different signal rather than my regular unit step signal. And that is why, because remember, unit step signal represents the unit values, which means one value. And what happens when you multiply anything with one, right? Whenever you multiply anything with one, you will get the same number. And same thing will happen with the signal. Whenever you multiply your signal with unit step signal, you will get the original signal as it was, as in right in its original form. So if we multiply the ramp signal with unit step signal, we will get the ramp signal back. So in order to avoid that, because if we do that, how would we understand? We would not be able to understand, we would not be able to grasp the concept. So to grasp the concept, we have changed the signal a little bit. So let's see what happens here. Again, we are following the same formula again here. This is my unit step signal. For my unit step signal, what value I'm having at t is equals to 0? It is having value 0. And at t is equals to uh, 0, this signal is having also value 0. We are going to multiply both of these signals, right? So what we are going to do, we are going to simply multiply both these values. So 0 into 0 will be 0, so we will take this point 0. Then we will take the value t at t is equal to 1. So t equal to 1, what is the value of this signal here? It is having 1. And for t is equal to 1, what is the value of this signal here? It is having minus 1. So 1 into minus 1, what will it be? It will be minus 1. So we'll plot minus 1 here. Now let's see for t is equal to 2. For t is equal to 2, this one is having value 2. Amplitude's value is 2. And for t is equal to 2, this signal is having value again minus 1. So what will happen when we multiply minus 1 with 2? We will have value again minus 2. Same for t is equal to 3. What we are having, t is equal to 3, again we are having value 3 for x2 of t, and x1 of 3. For t is equal to 3, we are having value minus 1. So 3 into minus 1, again we will be having value minus 3. So we have mentioned this value here minus 3. By the way, we are considering this grid as a unit, so this will be minus 1, this will be minus 2, and this will be minus 3. So we will having value minus 3. And now for t is equal to 4, this signal is not moving further, so it has been stopped. This signal is having value 0, so anything multiplied with 0 will be 0. So here this signal will look something like that. So this is the multiplication of the signal, or the product of the signal, for continuous time steps or continuous time signal. Similar thing will happen, similar formula we will be following with discrete time signal as well. See here, for value minus 1, we are having value uh, for t is equal to minus 1, we are having value 1, and for t is equal to value minus 1, we are having value here minus 1, so 1 into minus 1 we will have value minus 1. For t is equals to minus 2, we are having x1 of n is having value 0. For t is equals to minus 2, x2 of n is having value minus 2. So anything multiplied with 0 will be 0. Same thing here for t is equals to n is equals to 0. For n is equals to 1, x1 of n is having value 1 and x2 of n is also having value 1, so 1 into 1 will be 1. For n is equals to 2, here we are having 0 value again, so anything multiplied with 0 will be 0, so again 0. For n is equals to 3, x1 of n is having value 3 and x2 of n is having value x1 of n is having value 1 and x2 of n is having value 3, so 3 into 1 will be 3. So that is your same multiplication operation for discrete time steps. Now let's see the differentiation of a signal. So let's say if my signal x of t is a continuous time signal. Okay, so how do we give the derivation of this continuous time signal, right? We will give the derivation using this formula: y of t is equals to d by dt into x of t, right? And for example, the inductor will be the ideal no, inductor will be the ideal source, you can say, which performs the differentiation operation, right? So see this figure on the right hand side. What happens when this current passes through the inductor? The voltage which will be induced across this inductor will be given by v of t is equals to L di by dt I of t, right? So see, you are getting the similar pattern of these and these. So what is it? It is nothing but the differentiation of my signal. Similarly, we can see the integration of my signal. This time let's see x of t, and I want to integrate this signal with respect to time. So what we will do, we will take the integration on the scale of minus infinity to t, and we will take x of tau into d tau. So you must have a question, what is the tau here? So it is nothing but integration variable. Whenever we will go through the sum, you will get understand it better. And again, an ideal scenario, a good example of this will be the capacitor. So what it does, it performs integration operation basically. Let's say that I of t is the current which is passing through the capacitor, right? So what will be the voltage which will be developed across the capacitor? So voltage developed across the capacitor can be given as v of t is equals to 1 by c integration minus infinite to t I of tau into d tau, which is similar to this operation. So what is happening here? Again, here happening nothing but integration of signal operation is taking place, and uh, uh, capacitor is a very good example of this integration process. So let's keep this lecture till here, and I will be seeing you in the next lecture with a very new topic. This was the very first video of this playlist. So if you haven't checked out the previous lecture series, please check that out, because it is mandatory to understand this lecture series that you have checked out the previous lecture series. And if you have any doubts or any any feedback, any suggestion, you can mention it in the comment section below, so that I can clear your doubts, and I can get back to you as quick as possible. So I will be seeing you in the next lecture. Thank you very much for listening.